Remember, a relation is a function if each value in the domain produces one and only one answer in the range. We say that a function is one-to-one if each answer in the range is produced by one and only one number in the domain. So to check a function algebraically to see if it's one-to-one, what we can do is take two numbers, a and b, and see if f of a and f of b are equal. Then we know that a is equal to b. So the only way that f of a can be equal to f of b, in other words, two answers in the range, must be equal if the two numbers that generate those answers are equal. So what we do is we take f of a, which in this case would be a negative 3a plus 7, and f of b, which is a negative 3b plus 7, and set them equal to each other. Now we need to do the algebra on this and see, do we come out with a equals b? So this is a negative 3a plus 7. This is a negative 3b plus 7. If we subtract 7 from both sides, we get negative 3a and negative 3b. If we divide both sides by negative 3, we come out with a equals b. So f of a equals f of b does give a equals b for this one. Therefore, it is one-to-one. And now f of a would be the square root of 49 minus a squared, and f of b would be the square root of 49 minus b squared. So if we set those equal to each other, do we come out with a equals b? If we square both sides, the square roots will disappear and we'll have 49 minus a squared and 49 minus b squared. If we subtract 49 from both sides, we'll have a negative a squared and a negative b squared. If we multiply both sides by negative 1, we'll have a squared equals b squared. Now, I can tell by looking at this that there are numbers. For example, if a is a 2 and b is a negative 2, then a squared is 4 and b squared is 4. Now those are actually equal to each other, even though the a and the b are not equal to each other. So because f of a equals f of b, we do not have necessarily a equals b. Now remember, if we do the square root of both sides of an equation, we have to put a plus and minus on there. So we would come up with a equals plus or minus b. So there again, that does not say a equals b. It says a could be equal to b or a could be equal to negative b. Therefore, this is not one-to-one. Now, if we have a graph, to determine if the graph is one-to-one, we use what we call the horizontal line test. Now remember, the vertical line test was used to determine if it is a function. For this graph, if we put a vertical line anywhere on the graph, it touches in one spot. Therefore, by the vertical line test, this is a function. Is it one-to-one? If we put a horizontal line here, you notice it touches in two spots. By the horizontal line test, this is not a one-to-one function. It is a function, it's just not a one-to-one function. Similarly, by the vertical line test, if I put vertical line anywhere on this graph, it's going to touch in one spot. Therefore, the vertical line test tells us that is a function. Is it one-to-one? Here is a horizontal line, and another, and another, and another, and another, and another. Now it's kind of hard to determine here in the middle whether or not it touches in exactly one spot. However, I'm assuming that it does. Therefore, this one is a one-to-one function. Meaning that it has an inverse. To determine if two functions are inverses, we do the function composition and see, do we get just an x? So here's the function f, 2x plus 5, and then the function g, 1/2 x minus 5. So if we do f of g, we get 2 times 1/2 x, which is just an x, and 2 times -5, which is -10. Now -10 plus 5 is -5. So the composition f of g gives x minus 5. It does not give x. Therefore, these are not inverses. To find the inverse of a function, we should first check for one-to-one, because if it's not one-to-one, there's not an inverse, so we don't have any work to do. I do recall from an earlier chapter that the graph of absolute value of x is a V-shaped graph, and I can look at this and tell by the horizontal line test that this is not one-to-one. Therefore, I don't need to find the inverse. I know from back in the very first chapter that the graph of 4x minus 7 is going to be a straight line with a y-intercept of -7 and a slope of 4. So that would be up 4 over 1. So the graph would be a diagonal line. Diagonal line would be one-to-one. So therefore, this does have an inverse. The steps for finding the inverse are: number 1, change the g of x into y. Number 2, swap places with x and y. And finally, solve that equation for y. If we add 7 to both sides, we get 4y equals x plus 7. If we divide both sides by 4, we end up with y equals x plus 7 divided by 4. Now, the x plus 7 divided by 4 is called f inverse of x. You can use either of the methods that we talked about earlier to determine that this is a one-to-one function. And here are the steps for finding the inverse of that. Number 1, we'll change the f of x to a y. Number 2, we want to interchange the x and the y. So we will turn this y into x and these x's into y's. Now, step 3 is to solve for y. As with any equation involving fractions, we'll begin by multiplying by the common denominator. That will make this into an equation without fractions. And we'll use the distributive property to make this an xy minus a 5x. We need to collect all of the y's together on the same side. That means the negative 3y needs to go to the other side. We do that by adding 3y to both sides. That disappears. Nothing combines. We need the 5x over on the other side. We will add 5x to both sides. We will factor the y from the left-hand side. And finally, divide both sides by x plus 3. And we also will recognize that x cannot be a negative 3. And so our inverse is 1 plus 5x over x plus 3, and x cannot be a negative 3.